Hello everybody, my name is Eric. Today we're going to talk about Cloudflare, the internet going down, internet centralization, and a bit more. So we'll take a look first of all at this by Matthew Print. So what happened? Yesterday, basically every website on the internet, or a large amount, not all of them obviously, went down. Why did this happen? Because Cloudflare's proxy, which is a protection service that many websites use. It's basically like a VPN, but for your website. So what it does is you put your web server, like you normally would, you give that IP address to Cloudflare, and then Cloudflare takes that, puts it on their proxy network, which protects you from DDoS, because if they try to DDoS your domain, it gets DDoS, it goes to Cloudflare. They also do some caching, and they provide some other good services. It's a good product. But it's really designed in such a way that a lot of the internet will go behind it. It's not feasible to DIY your own DDoS protection, and a bigger DDoS protection network is going to be more resilient. So this is what happened. On the 18th of November, Cloudflare's network began experiencing significant failures. Core network traffic was down. This is what you saw if you tried to access any website that uses Cloudflare. And this affected pretty much everything. Any ROM was down, which actually affected the publication of a video because it was sponsored. Tons of stuff. And even if Cloudflare wasn't in use, sometimes there would be a dependency, even Down Detector, the website that tells you if things are down, briefly went down, which is kind of hilarious. This issue was not caused directly or indirectly by a cyber attack or malicious activity of any kind. Now, they're making that clear. It was actually caused by a database system's permission, which then caused more data than expected to be outputted into a feature file. The feature file is because the bot management system uses machine learning, not like in the ChatGPT sense, but the more classical machine learning where you have some set of input features. And the basic idea is that we have a set, which is a bunch of numbers. That's the features. Then our machine learning model does something with them and then produces an output. In this case, it was producing a probability that the user was a bot. So it would say, this looks like it's probably an AI scraper. Or it could say this looks like a human. That's what the system did. And these features would be things like your browser's user agent, what operating system you're running, your IP address. They can even look at stuff like how you move your mouse, because of course a scraping browser is not going to move its mouse like a human would, how you scroll the page. All of that can be used to help make a determination on whether you're a human or not. It can also catch simple mistakes. Like let's say you're on a Linux server running headless Chromium and you spoofed Windows. There are ways through pixels to check that, and it's actually very obvious if the system is smart enough. So that's what it would do. And the feature file essentially, I guess, would have had the weight. So when the firewall received a feature file that was bigger than expected, because of some performance optimizations, that completely broke. Now, this needed fast deployment. It's a bit like CrowdStrike in that sense, where we needed fast deployment because this is the file that has to keep up with the threats or the bots. It had a limit, and that was the problem. Now, the reason they did that, and we'll look at that in a bit, was because of a low-level optimizer. So initially, they thought the problem was a large-scale DDoS attack because it was weirdly intermittent. But when they figured it out, they were able to fix it. Now, this was down for hours, which was surprising, and it took quite a while. So, of course, here Matthew is apologizing, given the large impact. So, here we can see. So, everything was good. Everything was good. Spike, and then it kind of came up and down, which is not what you normally, if you screw up your code, right? Usually that instantly breaks everything. But there's a reason. Files being generated, and they were using a cluster. Some of the cluster had been updated with the bad output, and some of it still had the good output. So as a result, the file could either be generated good or bad, which created an intermittent issue until the update fully rolled out. Solved it by shutting that down and simply propagating a known good until they had fixed it. So basically everything Cloudflare does went down. So here is the proxy that we explained a bit earlier. So the security checks go through. There's a machine learning model that will take a bunch of data and try to figure out if you're a human. Now, they use ClickHouse for computing these feature rows, and they changed a permission, and their queries were written in a certain way. This seems like weird design that led to an oversized file being generated. So these error codes, and they've also, unrelatedly, been working to switch their proxy to a new one that is written in Rust. And a lot of people have been dunking on this because the Rust one catastrophically failed, while the legacy one failed in a different manner. So the Rust one ultimately panicked. That is the correct term for Rust. The old version, FL, did not see errors, but bot scores broke. So if you had bot protection, to my understanding, any visitor would be blocked. So this actually would have been the same outcome. But of course, if you didn't block bad bots, if you said, you know what, I'm going to allow all the bots, then your site would still, whereas if you were on the new proxy, that wouldn't work. Now, the other thing that happened was their status page went down, which they say is not hosted on their infrastructure so that it will stay up if Cloudflare goes down. So they thought an attacker was heavily trying to DDoS them into the ground, or it is big botnet flexing. So what actually went wrong? Well, the query behavior changed. So this is a distributed database. They have distributed tables, and the database is called default. So this, which was designed in such a way that under previous assumptions, this would have returned only the features. Well, now, because it's not querying by database, that started creating a monster file. So here's why it ultimately broke. Now, the reason why you would do this is because pre-allocated fixed size memory is using that is generally going to be faster than dynamically allocating memory on the fly. Now, in the Rust version, there's an unwrap here. So features struct, then we do append with name, and then we do unwrap. Now, in Rust, an unwrap will simply terminate if the result doesn't go as planned. If you get an error, if you get an OK, you get the result. That took down a lot of Cloudflare. So what are they going to do? Well, it's a big one. Anyone who's into Rust would tell you using unwrap in production code is a no-no. There are exceptions, but unwrap should only be used if the condition is impossible. If you know, like your code generates everything, you know that a condition can only go one way, using unwrap can be more convenient than pausing it. In production level code, otherwise there should be some sort of fail-safe here so that this doesn't happen, because unwrap just terminates the worker, as we can see here. It just fails. Now, Cloudflare had previously operated under the assumption that Cloudflare generated configuration files, and in general, stuff from their infrastructure, they didn't have to cleanse and be as careful pausing as they did with user-generated content. Well, they're not going to do that anymore. They're going to enable global kill switches, try and catch this sooner, eliminate that, and review failure modes for all error conditions. Yes, this was the worst Cloudflare outage in years. Pretty much everything except for Google services was taken out, because Google has all of their own infrastructure, right? So YouTube, Google search, that still worked. Ironically, given Google was launching Gemini 3 yesterday, Gemini was the only AI service that was still working. So they also won on that count. And unfortunately, it's very difficult to run a website these days without this kind of DDoS protection. And as a result, you end up with a situation where only very large companies can do it. This is a different centralization problem than what we talked about before, when Google Cloud and AWS took down large amounts of the. That's happened a few times, and at least there's an easy solution for that. I mean, there are many companies you can host your data with. You don't have to use AWS if you don't want to. You can just rent a dedicated server. Technically, you can buy a server and put it in your house. You can, if you're a company, you can get your own data center. You have a lot of choices with that. With DDoS protection, you're more limited. There are enterprise-grade solutions at the internet service provider, like, for example, Zayo has DDoS protection. You can get, for a data center, you can get fiber from them, and you can get DDoS protection built into that. That's an option. That's a higher level DDoS protection. And there are open source services you can try, but they're generally limited because the way the DDoS protection works, it absorbs the attack. So you need a huge amount of resource. It's a big problem, really, with the internet and the way it is designed, DDoS attacks. And there isn't a ton that can be done. And it's like, it's a weird thing because it's not really, well, it's not like other cyber attacks where data is stolen. It's just, as they say, it's a denial of service attack. In fact, just the day before Cloudflare went down, the largest ever DDoS attack hit Azure with billions of packets a second. So DDoS protection, definitely not something the internet can live without. And unfortunately, the way things are currently going, the main way to mitigate it is highly centralizing on one service. And as CNN is pointing out, yes, it's the consolidation of critical infrastructure. There is no such thing as 100% reliability. And when it used to be, and I even remember this a few years ago, when there was a problem, be like, oh, Reddit's down, okay. Or, oh, YouTube is down. That happened every so often. But with all of this centralization, companies everywhere went down. Even X went down for a bit, although I think they were able to get back up, which is because they don't use cloud servers. They have their own data center. So usually that then gives them their own reliability profile, but they were not 100% independent, and it's very hard to be. And there's not a lot that can be done. It's concerning to me. And it's sort of concerning in general how much power Cloudflare in particular has. Matthew Prince himself has even made this point. He's written blog posts. Cloudflare, as a rule, are pretty permissive. They don't like disconnecting customers. I mean, they put up with, like, I know when they finally took down 8chan, he even said he wasn't 100% comfortable with that decision. And there's a problem, Cloudflare is a private company, primarily going to be driven by fiduciary duty to shareholders. It's not really a good system where so much of the internet relies on this company, which has mostly acted in good faith, which is good. But, we ideally, there would be more competition and more diversity in the internet host and DDoS space. So that's going to be all from me for now. Please let me know what you think in the comments below about internet resiliency, and of course about the whole Rust thing. I think I've said this before, any rewrite of software, unless you were dealing with like terrible code, any rewrite of software is going to, in the short term, hurt reliability. Code that is battle tested, has been in production for a long time, is more reliable than new code. So any migration does introduce. I don't think this Rust code was great, but I don't think Rust, or even that Rust code, ultimately isn't the main issue here. So that's going to be all from me for now. Please let me know what you think. Bye.